Hello students, in this session we will see the chapter of motion in a straight line. Got it? See, as the name of this chapter suggests, the object is going to move in a straight line, which means you are going to have one-dimensional motion, and then we will be studying properties related to those one-dimensional motion, right? So the stuff that we will see in this chapter are distance and then the displacement. Okay, there is some difference between distance and displacement. We will see that one, right? The next thing that we will see is like velocity and acceleration. Got it? So in velocity also you have like two terms, which is like speed and then velocity. You have difference into it also, right? So we'll see that one, and then velocity and acceleration. Got it? So in order to understand this stuff clearly, velocity, acceleration, we need to know differentiation and then the integration. Got it? So differentiation and integration, they both are closely related, right? For example, if you are going to do it in forward direction, that is called as differentiation, and then if you do it in other way around, we'll consider that to be integration. We will see all those logic behind it, right? So the stuff will be like distance and then velocity and then speed, I mean acceleration. So these are some things that we will see, right? So this will be the foundation for this chapter. Then from that we will see like graphical things to it, right? If the distance is going to change in some fashion, then how will the velocity be related, or how will the acceleration be related? So all those graphical stuff we will see in this chapter, right? So this will be like a first section for this chapter. Then comes like kinematic equation. Got it? So kinematic equation is something that you might have learnt in your lower grades. It's like b equals u plus at, s equals ut plus half at square. Those equation you should have already known. This equation, we will see the proof and logic behind those kinematic equation. Got it? From one dimensional motion itself we will be able to derive kinematic equation. So we will see all those three equations. Fine. So the last part for this chapter will be like relative motion. So in relative motion we will just see overall picture of understanding of relative motion. We will build up relative motion using like motion in a plane, which is like the next chapter, two-dimensional motion. And when three-dimensional motion comes into picture, you will be able to get a clear-cut idea of more relative velocity. As if now we will see the basic intuition and logic behind relative velocity, right? So that will be good enough for the sums that we are about to solve, right? So that logic itself is enough. We'll use that logic to build up to solve the sums, right? So while doing sums, you'll get a much more clear in-depth understanding of sums. As if now in the theory part, we'll just cover the intuition behind the relative velocity. Okay, so these all are the things that we are about to complete in this chapter, right? So the sessions that are needed to complete this chapter, like it's like 2 sessions is supposed to be needed. So in that 2 sessions, which means in the first session, in this session we'll complete till integration. Got it? So we'll do like distance, displacement, and then we'll do like integration, differentiation. So that is what we will do in this session. So in the next session we will do the graphical part, which means acceleration, speed. Graphical part is something that will be dealt in the next session along with kinematic equation and relative velocity. Okay, so we need around 2 sessions to complete this chapter, right? So let's jump into it. Let's see the first part, which is like rectilinear motion. See, rectilinear motion is nothing but a new term that is given for an object that is moving in a straight line. Okay, so rectilinear actually represents something. When an object is moving in a straight line, we'll call it as rectilinear. That is why this is called as rectilinear motion, right? I have just given this term so that you should know this term also represents one-dimensional motion. That's why I've given this term. Okay, so rectilinear motion actually means object is moving in a straight line as usual, right? I'm just writing the heading once again, that's it. Got it? So when an object moves in a straight line, which means one-dimensional motion, I'll call it as rectilinear motion. Got it? So the next thing is like mechanics. Fine. So mechanics is actually a bigger part. Okay, we'll have like 2 subcategories into it. In mechanics we have like 2 categories, which is like statics and then dynamics. Statics, and then you have like dynamics. Fine. So statics, the name itself clearly represents. Statics means you are going to study that object when it is at rest. Okay, static actually means rest, right? This is something that we know. So statics means when you do something like statics, hydrostatics. In physics we will do that one while doing mechanical properties of fluids. Hydro means actually water. Statics means when it is at rest. So we'll study the property of water when it is at rest. How will the pressure change, and all those things will be dealt. So when you are going to study the nature of a material or nature of a substance when it is at rest, we'll call it as statics. Got it? So in statics means when an object is at rest, we will study its property. Got it? So the next comes is like dynamics, and then we have like two parts into it. Fine. So dynamics should obviously represent when an object is in motion, we'll call it as dynamics. Got it? So in this dynamics, you actually have two categories. Got it? So you have like two subcategories in dynamics. So mechanics splits into two parts, which is like statics and then the dynamics, right? So everything, all those Newton's laws, everything, Newton and mechanics, everything falls into this part, which is like mechanics, and then we'll be able to split it into two things, which is statics and then dynamics. In dynamics, you have like two extra subcategory, which is called as kinematics, and then the second one is like kinetics. Right, so we have like two subcategories into it. The first one is like kinematics. So in kinematics, we will study the motion without considering the cause, right? So if you have to push an object, you need to give force to it, right? If I don't study the cause, which means if I don't consider the cause, which means the force acting on that object, and then I'm just going to study the motion. So what if I'm about to study only the motion without including the cause, which means the force, I'll call it as kinematics, right? So the first two sections, first two chapters that we are about to study, which is like motion in a straight line and motion in a plane, these two will fall into the category of kinematics. Then we will do like laws of motion. While doing the third chapter, which is like laws of motion, I will include force into it. They will come under the category of kinetics. Okay, so if I include the force, then it comes into the category of kinetics. If I don't include the force, it comes into the category of kinematics, right? You should, these are like overall understanding, that's it, nothing more is needed into it. So for kinematics, I'll have to consider the, I shouldn't consider the cause. So cause is the force here, so force shouldn't be considered, or force not included, right? So kinematics should be clear. Then comes kinetics, where I'll study the cause. Okay, so if I'm about to study the cause, that is like kinetics. So you have like force included in the second part, right? So from laws of motion chapter, we will include force, right? So force is something, I'll use the term only in the third chapter, right? So the first chapter is like motion in a straight line, then comes motion in a plane, and then comes like laws of motion. So these are the foundations for the physics. Got it? Units and measurements is something a separate category, right? Okay, so in kinematics, we will not include the force, and then in kinetics we will actually include the force, right? So these are the splitting that we need to know. So now let's jump into the theory part, important part, right? So there are like two things, which is like distance and then displacement. From in the lower grades, we might have considered both seems to be like the same parameter, but as if now you should know to segregate the difference between distance and then the displacement. Okay, these two things are not the same idea, right? So displacement is something that comes in the physics. Distance is something that you don't get in the physics. Got it? Right? You should know that there is like one difference which is important. You should know that one. The first one is like distance or path length, both represents the same thing. This is actually a scalar quantity. Okay, so scalar means it doesn't represent direction. So we will do scalar, vector and all those things in the next chapter. Motion in a plane, we will do in depth into it. As if now what you are supposed to know is distance or path length is actually a scalar quantity, which means it doesn't represent the direction, which means it doesn't tell you whether you are moving in a north direction or you are moving in a south direction, right? We will represent all those things by vectors I cap, j cap and k cap. We will do that stuff in the next chapter. As if now what you need to know is distance or path length is just like an scalar quantity, which means it doesn't represent the direction in which you are moving, right? We'll do an example for it. And then you have the next one, which is like displacement. This is vector quantity. Okay, so vector is something that comes into picture in the physics. Therefore displacement is the only thing that we use in rest all other physics that we are about to study, right? Got it? So in the first case, it's like a scalar and this is like a vector quantity. So in scalar, the second point that comes into picture is from the first point itself, we'll be able to do the second point, which is like when you need to measure the distance, you need to know the whole history, right? How did we move? In what direction and all those things is needed. Just we'll sum it up. So as far as distance is concerned, whole history is needed in order to measure the distance. Okay. So whole history is needed. Only when you know the whole history, I will be able to get the distance. The next one is like displacement. In order to get the displacement, just n points are enough, right? So what is the final point and what is the initial point? Those 2 points are just enough to find the displacement. Just subtract final point minus initial point, you will get the displacement. We will see examples for it. As if now, what you need to know regarding displacement is just n points are enough. Got it? I'll give you the explanation for the statements that I'm making here. Just n points are enough. If only you know the endpoints, we will be able to get the displacement out of it. Now let's consider a situation where a man is standing on a plane. Okay, so he is standing just on a plane, and this is like a one-dimensional motion, which means he will either be able to move forward, which is like plus x in this situation, or he will be able to move in reverse direction, which is like negative x, obviously, right? So either he will be able to move plus x or minus x, right? So it is in one-dimensional motion. In two-dimensional motion, we will include both x and y axis. That is when vector mainly comes into picture. As if now, what you need to know is if you are going to take one direction as positive, then the other direction should be negative. That is the thing that you need to know regarding vector. Okay, fine. So you are having a man who is standing at the origin. Okay, and then he moves forward to 3 meters. Okay, so he is moving like 3 meters forward in the first instant. Got it? So in the front direction he's moving like 3 meters forward, and then he holds there for some few minutes, and then he again walks in forward direction for extra 2 meters. Okay, for extra 2 meters, so you'll have like another 2 meter coming into picture. So now totally you have like 5 meters into it. Then what he does is he just moves backward, right? So he just moves backward from 5 to 2, which means he is just moving 3 units backward. So you'll have like 3 units backwards, which is like negative 3 meters, obviously, right? So plus 3, and then you got like 2 meters, and then he is moving backwards again 3 meters, so that finally he is at a position of 2 meters, right? So in order to measure the distance, what I've told you is I should know the whole history. So I should know all those things that has happened. That is when I'll be able to measure the distance or path length. Both are just the same term, okay, in physics. So only when the whole history is known, I'll be able to get the distance or path length. Here the whole history is like 3 plus 2 and then plus 3, right? You shouldn't consider the sign in this situation because this is not a vector quantity. Only when you put vector into picture, so vector is something that plays in the entire role in physics. You do not know the history in the case of physics, right? So only the final point and initial point is just needed while calculating displacement. That is something that is needed in physics, but distance or path length is something that only when you know the happenings that has happened in that situation, we will be able to calculate the distance or path length. Okay, so here you shouldn't consider the sign. Whatever the sign it is, just the distance that you have covered, that should be added, right? So here it will be like 3 plus 2 and then plus 3, right? So altogether it comes to be like 3 plus 3 is like 6, 6 plus 2 is like 8 meters. So for the situation that I have given underneath, the distance or path length will be like 8 meter, right? Fine. So what will be the case in the case of displacement? So in displacement, just final points is enough, right? So the final point here will be like 3, I mean like 2, that's where he is standing at the end, 2 and then minus 0, right? So that will give me the displacement, obviously, right? Just n points are enough. That's the statement that we have made. Therefore here in this situation, the displacement is obviously going to be like plus 2 meter, right? So either you could consider plus 2 meter, which means like final point minus initial point, or else if you just include the direction, you'll get the same answer, right? 3 plus 2, which is like 5 meter, and then negative 3 meters, right? Then you have like 5 minus 3 meter, which will again give you 2 meters, right? Either you can consider the direction or just put the final, take the final point and subtract it with the initial point, you'll get that displacement. Got it? But as far as distance or path length is considered, you'll have to be clear, right? You should know the whole history, what all are the direction that he has traveled. Take all those direction excluding the signs, then you'll get the distance or path length, right? So these are something that you need to know regarding distance and path length. Then we will see some graphs into it. The graphs here are related between x and then the t, right? So if they're given you just x, you should be clear, it should always denote the displacement. Okay, if they are given you any specific situation as distance, then it represents distance. In physics, you will consider one direction motion in x-axis, which will always be displacement, right? So here x is nothing but the displacement, and the time t is the time, obviously, right? So here what actually happens is there is an object which is at a distance of 4 meter. Okay, there is a man who is standing at a distance of 4 meter, and then as the time passes, still you get the answer to be the same 4, which means he is not moving, right? Even though the time is increasing, the man is not moving, therefore you get the same x, right? So a guy is standing in 4 meter and then he is at rest. So for the first graph, you will get rest or else stationary object, right? When an object is at rest, you'll call it a stationary, right? So you have like stationary object. in this situation, right? Then let's consider the second case. In second case, obviously, as t is increasing, x is also increasing. For example, a guy is standing on origin, which means at 0. Then what actually happens is he is moving along x axis, right? As time passes, his x distance is also increasing. Displacement is also increasing, right? So he is moving along the x axis. Same way, the time is also increasing. Got it? In this situation, he is moving in an uniform pattern. That is why I get a straight line, right? Therefore, this motion is actually uniform motion. You have some, you will be able to interpret this one in some equation. Okay, we will do those things when we see the graphical section. We'll do those things. Therefore, for the second graph, I'll be able to write uniform motion. Fine, there shouldn't be any doubt into it. Next comes the third graph. So while looking at the graph, it is pretty clear. X keep on changing in random fashion with respect to the x, which means the time, right? So x displacement keeps on changing in a random fashion with respect to the time. Then obviously this should be a non-uniform motion, right? No doubt should be there related to it. Therefore, this motion is actually non-uniform motion. The next stuff that we are about to see is like speed and velocity. You should be able to judge by this time. One should be like vector and the other one should be like scalar. Let's see what is vector and what is scalar. Which parameter denotes vector and which thing denotes scalar. We'll look into it. So speed, right? So speed is actually a scalar quantity, whereas velocity is actually a vector quantity, right? Therefore, the first term is like scalar and the second term is like vector. Got it? So, for example, if you're on a bike and then it shows the speedometer shows like 50 kilometer per hour, which means if you go with that constant speed, you will be able to cover 50 kilometers in 1 hour. That's what that speedometer represents, right? So, in order to get speed, what you should do is you'll have to consider the distance and then divide it by the time interval, right? So if you are going to multiply the time interval to it, you'll get the distance covered, right? Obviously, fine. So for example, if the bike is moving with a speed of 50 kilometer per hour, and then if you are about to multiply it with half an hour, which means half, you'll get like 25 kilometers. That is what we will be able to cover in half an hour, which is equal to 25 kilometers. So same logic here. So here what I'm about to do is I'm going to find the speed, right? So I know the distance and I know the time. If I divide it, then I'll get the speed out of it. Got it? So speed is a scalar quantity. Then what I should put in the numerator is actually distance or path length, right? So in the case of velocity, I'll put displacement, right? So same logic, whatever we have seen with respect to displacement and then the distance, we will do the same thing here also. Speed and velocity. As usual, velocity plays a role in physics. Speed doesn't come into picture because if I need to know the speed, I'll have to know the path length, which means I need to know the whole history. That is not possible, right? Therefore, speed is nothing but change in distance divided by time interval. Got it? So, speed is nothing but change in distance or path length. I'll put only distance. Got it? Divided by time interval. So when you get question that is related to distance and path length, you will have to be careful, right? Distance and displacement, you'll have to be careful because at times they'll ask you to find distance, okay? At times they'll ask you to find displacement, right? You should be careful. While doing sums, I'll show you those kind of sums, okay? But as far as physics is concerned, in upcoming chapters, there are times where you'll get distance into it. You'll get to know the term distance actually represents displacement, right? Because in majority of the physics that we are about to study, displacement plays the role, right? Distance doesn't come into picture. In those kind of questions, when you have a term like distance, you yourself will get a notion, okay, they have given you the displacement. That is something that you'll know, right? Fine. So while doing question, I'll show you the difference, how to find answers to it, right? Got it? Here you have like speed. For speed, you have like change in distance divided by time interval. Right? For velocity, you have like change in distance. Instead of distance, I'll put like displacement divided by time interval. Right? This should be clear. So now we have studied the difference between speed and velocity, right? In order to get a detailed understanding of velocity, we need to get instantaneous velocity at every instant. That is something that we need to find, right? So in order to get that one, we will jump into new max concept, which is called as differentiation, right? Once you are clear with differentiation, then integration falls into picture, because if you do integration in one direction, if you do it the exact opposite way, the other way around, you'll get integration into it, right? So differentiation is something that we will see like more intuitive into it, intuitive thinking into it. Once you are thorough with differentiation, then obviously integration will fall into picture. Okay, let's jump into differentiation. Let's see what differentiation actually is. For understanding differentiation, first let's consider a simple equation, right? We'll consider a linear equation, which is like y equals 2x, right? So if we just develop an oral understanding of this linear equation, from that we will be able to build the concept of differentiation, right? So the concept of differentiation revolves around the slope, right? So this is slope is something that you should have learned in your lower grades. We will see what is meant by slope also. From that slope we will build the concept of differentiation. Got it? So here we'll consider a simple linear equation, which is like y equals 2x. So let's plot a graph out of this equation. So when I'm about to plot the graph, this is like x-axis and this is like y-axis, obviously. So y equals 2x, which means for every single movement in x for 1 unit, you are about to have 2 units movement along the way. That's what this represents, right? So if I am about to substitute the points, for example, if I substitute x equals 1, then you'll get y equals 2, right? So that will be the point. For x equals 1, y will obviously be equal to 2. So that's the first point that you have got here, right? So you have something like this 1 comma 2, right? Then if I'm about to substitute x equals 2, then you'll get the respective y to be 4, right? So for x equals 2, you'll get the y to be like 4. So the point that you are about to get is like 2 comma 4. So this is how you get the point. And then when I'm about to join this points, I'll get the straight line, right? So this is actually a linear equation. Therefore, it increases in a symmetrical fashion such that you get a straight line, obviously, right? That is why you call it as a linear equation, right? So this is actually a linear equation. The next one that we will see is like a quadratic equation. Fine. So in this situation, it is super easy to find slope. Whatever the points that you select, you'll get the same answer. Let's see what it is. So slope actually means what is the change in y with respect to change in x. That is called a slope, right? So change in y axis with respect to unit change in x axis is called a slope. For example, let's consider a point such that you have the first point to be like 0 comma 0 is the first point that I have taken here. Got it? And the next point that I'm about to take in this line is something like this 1 comma 2, right? So all those things falls from this equation. So let's find slope for this equation. Obviously, if you had known, you should know 2 will be the slope of this equation. Anyway, we'll see what is the logic behind it. So the first point that I have taken here is like 0 comma 0, right? The next point is like 1 comma 2. So in order to get the slope, what I should do is final point minus initial point along the y divided by final point minus initial point along the x. That will give me what is the change in y with respect to x. Let's see what it is. So here slope will be equal to 2 minus 0, right? First I should consider the change in y, right? So that is what I've written here, right? So change in y axis with respect to change in x. So I'll have to consider what is the change in y that should be in the numerator. Then comes the x along the denominator. Got it? So slope will be equal to final point minus initial point, which will be like 2 minus 0 along the y-axis, and same way it should be like 1 minus 0 along the x. Therefore the slope here obviously will be equal to 2. So this 2 actually represents for every unit increase in x, you are going to have 2 units increase in y, right? So obviously, right? So if you are going to have like 1 unit along the x-axis, then you'll have like 2 units along the y-axis. Same way, if I'm going to consider some other point, for example, like 1 comma 2 and then 2 comma 4. I'm going to take like different interval in the same line. Still, I'll end up getting the same answer. Obviously, if I'm about to get slope for these 2 points, which is in the same straight line, then you'll have like 4 minus 2 and then you'll have 2 minus 1. Got it? So this should also be equal to 2, right? So whatever the points that you choose, you'll end up getting the same answer, right? So in the first 2 cases, I took it in such a way that the difference here is like 1 unit. Even if you take multiple units along the x, still you'll get the slope to be the same answer. That will be the third situation that I've considered here, which is like 0 comma 0 and then 2 comma 4. Here I have moved 2 units along the x, right? So if I'm about to get the slope for it, you will have something like this, s, which is equal to, what is the unit that you have traveled along the way? That's like 4 minus 0, and then along the x will be like 2 minus 0, which will again be like 4 by 2, that will be like 2, right? So whatever the points that you choose, you'll get the same slope, right? That is what this represents, fine. So for a straight line, it doesn't matter the point that you're about to choose. Whatever point you choose, you get the same slope. Okay, so slope is a convenient parameter for straight line. But in the case of a curvy line, the points that you're about to choose could be different and you end up getting different slope. So in that situation, the differentiation comes into picture. We will see about that one exhaustively in the next part. As if now what you need to know is slope for a straight line will be same irrespective of the point that you are about to choose, right? So the general formula that I can give for slope will be like slope, which is equal to y2 minus y1, got it? y2 minus y1 divided by x2 minus x1. This, you should be able to understand this one, right? That is what we have done in the below things. Okay, so y2 minus y1 divided by x2 minus x1, which will be like, I'm going to give a notation which is called as del. Okay, so del actually means final minus initial, right? So we will use this term again and again. We have seen this one and also in units and measurements also. Okay, got it? So you have like del y, del a mean and all those things, right? Del y divided by del x. Got it? So now we have found the logic behind the slope and everything. For a straight line, it is going to be same irrespective of the point that you are about to take, right? So then you have like two considerations that I have given you here. The first one is like a horizontal line and the next one is like an vertical line. So let's find the slope for both horizontal line and then the vertical line. Okay, so first I'll write the equation for it. So in the situation, in the first case, you're having an horizontal line, which means whatever the x that you take, you will end up getting the same y. So y is going to be constant, which is like 2, right? Therefore the equation will be like y equals 2. That's the equation for this line, right? Then for the next one, here whatever the y that you consider, you will have the same x, right? So for the next one, you will have like x will be equal to 2, right? Now I have got the equation. So these are something that you might have already known, right? So for the first one, it's like y equals 2. When it is an horizontal line, I'll denote it with y. Same way when it is in vertical line, I'll denote it with x. Okay, right? Now I'm about to find the slope for the first case and then the second case. For the first graph, slope will be like y2 minus y1, right? So you'll have like 2 minus 2. So that will be in the numerator, 2 minus 2 divided by x2 minus x1, which is like 4 minus 1. Obviously here the numerator is 0, therefore slope is obviously 0. So this 0 represents when you move units in x-axis, you will not have any increment along the y-axis, right? So that is what this 0 represents, right? Even if you move along the x-axis, there isn't going to be any movement along the y-axis. Therefore, here you'll have the slope to be 0, right? So this second graph is actually exact of this one, exactly opposite of this one. Therefore, when you do like y2 minus y1 divided by x2 minus x1, you'll have like 2 minus 1, right? You'll have value in the numerator, but in the denominator, you are supposed to get 0, right? 2 minus 2, which is like 0. Therefore, for the second graph, the answer will be like infinity. So here infinity represents that even though you don't move any units along the x-axis, you will have increment along the y-axis. Y keeps on increasing even though there isn't any movement along the x-axis. That is what this second graph represents. Okay, so this is like something that you might have already known, but why I am telling you this one is there are a situation where you get slope to be 0. When you get slope to be 0, then it actually means it is an horizontal line. Okay, if you get a value to be infinity, then it actually means the line is vertical. So that is something that you need to know, right? So these are the foundation that is needed to build up differentiation. So we will see differentiation using quadratic equation and all other equations, right? So we will see the proof of differentiation using the quadratic equation. Rest all other equation just falls into picture, obviously, right? So next we will see the differentiation of a quadratic equation. Next one is like quadratic equation. This stuff seems to be like confusing, but anyway, this one will be easy. While doing it, you'll be able to understand this one, right? Okay, so same logic that we have seen for the linear equation, we'll apply the same thing here. and we'll try to find slope using different points, and let's see how it is related. Okay, so the equation that I have taken here is actually y equals x square, right? So for every increment along the x, you'll have y that is about to change in the fashion of x square. So in square, the y is about to change. Okay, for example, if I'm about to consider 1 in the situation, for 1 it's like y is going to be like 1 square, again you'll get 1, therefore 1 comma 1 will be the first point in the situation. The next point that I'm going to take is like for 2, so for 2 you will get like 2 comma 4, right? So for 2 you'll get the 4, got it? Then for 3 it will be like 3 comma 3 square, which is like 9. Okay, so you'll have like 3 comma 9, right? So that is how I have plotted this graph. So obviously you will not be able to draw a straight line in this situation. If I'm about to join all those points, this line, I mean like this graph will look like a curve, right? So obviously y equals x square is going to be a curvy graph. Therefore what I'm about to do here is I'm about to find a interval, and then for that interval I'm just going to find the slope, right, by taking different intervals, same way that I have done with the case of linear equation. Okay, so here the first interval that I'm about to take is like del x equals 1, which means the point that I'm about to choose here is like 3 and 2 along the x. Okay, so x1 is like 2 and then x2 will be the greater point, therefore it's like 3, got it? So I have taken here 3 and then the 2, so corresponding y will be like, for 2 it is going to be 4 and then for 3 it is going to be like 9, right? So here you'll have for y1 it is like 4 and then for y2 it is like 9. So if I need to find the slope, then I'll have to subtract y2 minus y1 divided by x2 minus x1, right? So when I do the subtraction, you'll have like 9 minus 4 and then you'll have like 3 minus 2. So you'll have 5. So for the first case, you got the slope to be like 5. Got it? The interval that I have chosen here is like 3 comma 9 and then 2 comma 4, right? So if I am about to join these 2 points and then if I draw a straight line out of it, the slope of that line and the slope of this points that I have taken here will be like same, right? Obviously in that line I have chosen the point, then obviously the slope of that line and then those 2 points should have the same slope, right? Okay, so that is what I've got here. Next, what I'm about to do is I'm just going to reduce the interval in this situation, which means del x, I'm going to consider del x to be 0.5. Here 3 minus 2 was equal to 1, therefore del x was equal to 1. The next situation, I took del x to be like 0.5. In the case of straight line, whatever the interval that I choose, I'll get the same value, right? That's not going to be the case here. Let's see how does it actually change. So here the next point that I'm about to choose is like 2 and then 2.5. I'm going to choose like 2 and then 2.5. That's the interval that I'm about to choose here. Now let's see what will be the y that I'm about to get here. So the next is like 2. If I square it, I'll have something like 4. In order to get the y2, I'll have to square this one, right? So if I square it, I'll get, so we do not want to square it and all. Just do the math by yourself. It'll obviously be like 2.5 the whole square, right? Okay. So when you are about to find the slope in this situation, which means like 4 minus 2.5 the whole square divided by 2.5 minus 2, which will be like 0.5 in the denominator. That's why I've given you like del x equals 0.5. When you do the math, you'll get the answer to be like 4.5. I know the answer straight away. That's why I'm writing it down. Okay. Anyway, the math solving is not needed in this situation. Fine. So you should know how to calculate the slope. That is what is needed, right? So in the first case, I got the answer to be like 5. Got it? For this line, the slope was equal to 5. The next what I did is, I just took a shorter interval, which means 2 to 2.5. So when I connect those two lines, the slope started decreasing. From 5, it just moved to 4.5, right? Okay, so then what I'm about to do is, I'll just take still more closer point to my initial point. For the third point, I'll consider the interval to be much more closer. Okay, so I'm going to consider it such a way. The first point is just the same thing, which means like same 2 comma 4 I'm about to take here. The next point is so close to the first point, right? For example, the interval is so small, therefore it will be like 2.1, right? So the next point is so close to the first point when compared to the above situation. And let's see what happens to the slope. Obviously it is decreasing, therefore the next slope should be less than 4.5. Let's verify it. So here the next point is such that 2.1 for x2, then y2 will obviously be like 2.1 the whole square, right? So if you do the math, y2 minus y1 and then x2 minus x1, you'll get the slope to be 4.1. Okay, so slope is actually decreasing, right? If you do the math, you will see like slope is decreasing and then it seems to be converging at 4, right? So let's try with one more interval which is much more closer than the 0.1. So the next interval that I'm about to take is like 0.01, which means the first point is like 2 in x1 and the next point is going to be like 2.01. So that is how I'm going to consider. So x1 is like 2 and the next point is like 2.01. So if I do the math again, y2 minus y1 and then x2 minus x1, I'll get the slope to be like 4.01. Got it? So in all those four situations, it started from 5, which means I took a larger interval. So when I had a larger interval, the line was something different. And then as I start moving, the point became closer and closer. So when it became closer and closer, there came an instant where those 2 points were so close such that both the points seems to be the same point, right? In that situation, I got the slope to be converging along 4, right? So what I'm about to do here is I'm just going to draw a graph using a graph sheet. So you take a graph sheet and then draw a graph for x equals y equals x square, and then take that point 2 comma 4. So you draw a tangent at that point. Okay, so if you're about to draw a tangent at that point, the slope of that tangent will be equal to 4. So that is what this represents. So here what I have found is slope for a quadratic equation. With respect to a quadratic equation, you will not get a constant slope irrespective of the interval that you choose, right? So you choose like different interval, you end up getting different answers, right? So here if I have to get a constant slope, what I should do is I'll have to take a point and then the next point should be the same point. So I'll have to make interval such a close thing. That is when I'll be able to get a slope for that particular point. If you're about to choose some other different point, what you should do, you'll have to find the same thing with respect to that point. Make the interval so close and get a slope out of it, and then make sure that it converges with some number, right? And then you draw a graph, then you put a slope for that then you draw a tangent for that particular point. When you get that tangent, the slope of that tangent and the number that you have got by making approximation will be the same thing, right? So this is a kind of answer situation that I've taken here. Therefore I got the answer to be like 4, some whole number, right? So what I need to get here is I need to get an slope for those particular points, right? So I get different answer for different points, right? So in order to get some variable that is related to it, I'll have to find differentiation into it. So now differentiation comes into picture. So differentiation actually means you just make sure the interval is so close such that the denominator del x seems to be like 0. So when that del x goes to 0, what actually happens is you will get a slope of that particular point, which is nothing but the tangent in that particular point, slope of the tangent in that particular point, right? Okay, so that's the logic behind it. Now what I'm about to do is for every situation I'll not be able to do this approximation, right? So I need some variables to get this answer straight away. That is what I'm about to do here. Next, what I'm about to consider is I'll put variables into this term, right? Instead of considering 2, 4 numbers, what I will do is I'll just put x1, y1, just put the variables and do the solving stuff. When I do the solving, I'll get an answer out of it. So when I have an answer out of it, for example 2x, 3x, I'll get some values out of it. So if I have 2x, something like that, if I just put for x is equal to 1, what is the slope? It's going to be like 2. If I get 3x or 3x square, I just want to substitute that x value, then I'll get the corresponding slope. That is how I'm going to do here. So when I do this one, you'll get the understanding behind it. Okay, so the first thing is like x1 and then y1. So for x1 and y1, what I'm about to substitute is like variables, which is like x, and then for y1 I'll be able to substitute x square, right? So this is my first point. The next point will be like x2 and then the y2. So the next point will be a little bit increment of the prior point that I've considered, right? Therefore the next point will be something like this, x plus del x. That will be my x2. Then obviously what should be my y2? It should be like x plus del x the whole square, right? You shouldn't have confusion in this part, x plus del x the whole square. In the above situation, I just used numbers to get a slope of a particular point, which is like 2 for the point 2 in this situation. I couldn't be able to do this thing again and again in order to get a slope for any points, right? So I should have a variable parameter from which I should be able to operate easily and get slope out of it, right? That is what I'm doing here. Therefore, here for the next case, if I have to find a slope, it should be like y2 minus y1 and then x2 minus x1. On the right hand side, I have put all those variables into it, right? Now I'm ready to find the slope. So here I'm about to subtract y2 minus y1, which will be like x plus del x the whole square, right? So I'll just do the squaring stuff. Then you'll have something like this, x square plus del x the whole square, and then you'll have 2x del x. Okay, So now I have squared it straight away and then I put it here. So this is like y2 minus y1. y1 will be like x square, right? Got it? So instead of x plus del x the whole square, I just squared it, right? So you'll have like x square plus del x the whole square, 2x del x. I just put it straight away, minus x square. In the denominator, you will have something like this, x plus del x minus x. Next we can do the solving. So here you have x is plus x square and then negative x square. So those two things will get cancelled out, right? Same way in the denominator also you have like negative x and then plus x. Those two things will get cancelled out, right? So if you consider the numerator, there is this one parameter that is common, right? Del x square, you have del x. Same way in the second part also you have like 2x del x. You still have del x, right? So let's factor out del x from that term. You'll have something like this. So if I factor out that one, you will have del x which is factored out. Inside the bracket you will have like del x plus 2x. That's it, right? In the denominator you have one more term del x, right? So here also del x will get cancelled out, right? So del x it will get cancelled out and then I'll just be left with 2x plus del x. So that's the term that I'm left with, right? So next what I'm about to do is, so this del x is the small interval that I'm adding into it, right? In order to get the slope of that particular point, what I should do is those 2 points should be so close such that the succeeding point is same as the preceding point, right? So it should be such closer. So when it is such close, then obviously del x should be 0. So this is when differentiation comes into picture, right? So differentiation is nothing but we are measuring the slope at every point in that particular graph. That's it. Simple logic, right? Okay. So here when limit del x tends to 0, del y by del x, right? So for this equation del y by del x, I'm just going to put del x tends to 0, which means I'm going to consider del x so close. That is what this represents. So I'll be able to write del y by del x as dy by dx. So this is the differentiation thing. So I'll be able to write del y by del x as dy by dx when limit del x tends to 0. Del x is so close, I'll be able to write this notation. This is like a notation that I'm giving here. So dy by dx, which is nothing but del y by del x such that del x tends to 0. Okay. So here, if del x tends to 0, what will happen to the parameter that I've got over there? Obviously, this del x should be 0, right? That is when I'll get dy by dx. So the answer here for dy by dx will be like equal to 2x because I've considered del x to be 0. That's the reason, right? So now I have got the slope for that particular point, which will be like 2x for this particular graph, right? So if I have to get the slope for that particular point, what I should do is I'll have to just put that x term into it, right? If y was related into it, I'll put the y, but in the situation y isn't related, therefore I'll just put the x term into it. For x term of that particular point, I'll get the slope for that particular point. Let's verify it. If I'm about to put 2 here, right, that is what we have found, right? It seems to be converging at 4. Let's verify it. If I put 2 in the situation, it's like 2 into 2, so slope should be equal to 4. Obviously that's the slope that I've got over there, right? So here I have derived an variable parameter. With that variable parameter, in the situation it was equal to 2x. So based on the graph you'll get different values also, but here it was equal to 2x. So here I found a variable term. If I'm about to put in those respective points, if it was like 2 comma 2, I'll put the x to be 2, then I'll get the slope 4, which is nothing but the slope of that particular point. If it was like 3, I'll put like 2 into 3, which is like 6, right? So for this point, if I need to get a slope, I shouldn't need to do this thing entire step once again. Just put 3 into the equation that I've got here, which means if I put like 2 into 3, 6 will be my answer. So slope for the point 3 comma 9 will be equal to 6, right? So this is like super easy, right? So for linear equation, whatever point that you choose, you'll end up getting the same slope. That is like linear equation. But for quadratic equation and things that are other than the linear equation, you'll end up getting different slope for the point that you're about to choose. That is when differentiation comes into picture. Okay. So same way, if it was some other equation, x raised to cube and all those things, you do the same step once again and then you put the variables into it. You do the solving stuff. When you do the solving stuff, you'll get a differentiated value. Okay. So when you get a differentiated answer, which is like dy by dx, the answer will be like 3x square. So that is how it is going to be, right? You'll have to do it once again to get that answer. So that thing is like hefty. I didn't include it in here. You can try it with your own self. For example, if it was like x cube, you just put x cube for x1 and then y1, and then for x2 and y2 you just put like x plus del x, and then you just put x plus del x the whole cube, right? So you just multiply the cube into it and you do the cancelling stuff, then you will be left with 3x square. Rest all other terms will have del x into it. When you put del x to 0, the only term that will be left is like 3x square, right? So you just do it by your own self. If needed, you could do it. You'll end up getting some oriented answers into it. From that relate similar answers, we'll be able to generate a common formula out of it. Let's see what it is. For y equals x square, that is something that I've done here. You got dy by dx, which was equal to 2x. Okay. Then for y equals x cube, you do the same stuff that I've told you here. You'll get a term without del x, only one term. That term will be equal to 3x square. Okay. Got it? Same way, if you do it for y equals x power 4, you'll get a single term which will be equal to 4x cube. So it seems there is a similarity between these numbers, right? Between these variables. So similarity seems to be such that, so I'll have to reduce the power by 1 and then I'll have to multiply the power as coefficient. That's what is happening here, right? If it was like x square, I'm just going to reduce this power by 1, which will be like 2 minus 1, which will be like 1, and then I'm going to put that number as a coefficient. That's going to be like 2x, right? So same thing here. I just put this number into coefficient and then I reduce the power by 1. So it's like 3x square, and then you got like 4x cube. So the generalized formula for y equals x power n will be equal to n x power n minus 1, right? So this is the only proof that we will see, that we have seen here. The same way you have proofs for all those other differentiated equation for like y equals sin x, y equals cosine x. You have all those proof, but that is not needed, right? So this is actually a physics class, so only the understanding is needed. So those proofs are just a mathematical calculations into it. You might search it on the internet. That's not needed anyway. The point is, you need to know the basic intuition behind differentiation. So if someone tells you what is meant by differentiation, it is nothing but a method to find a slope of every single point in that particular graph. That's what we are doing here. Okay, so you shouldn't have any confusion into it. So this is what you need to know regarding differentiation. Next, we will see like what all are the differentiated value that you need to know. In the next page, we'll see that one. So the next differentiation is for y equals sin x. The differentiated answer is dy by dx will be equal to cosine x. Okay, so you don't need to worry about the proof in physics. Okay, so in math you should know the proof and all those things. Okay, so you'll study proof in math as if now you do not want to know the proof for all those things, right? The thing is, you should know what all are the differentiated answers that you need to get. Okay, so we'll use all those answer while solving sums. Okay, so we have like for y equals sin x, the differentiated value will be like cosine x. For y equals cosine x, the differentiated value will be like negative sin x. Okay, so this will be like other way around, negative sin x. And then this is like a special case where y equals e power ax. Okay, so if I do the differentiation of this one, I'll get the answer to be like a e power ax. Okay, so that a comes to the coefficient and then you will have that value repeating once again. So e is a kind of a special number. This is actually an irrational number which is closely equal to 2.7, something like that. Okay, so you do not want to know much about that e. The thing that you need to know is this is an irrational number. Okay, so this number comes into picture because of differentiation. The way we studied pi, okay, we called it as an irrational number because that comes from the intuition of angle into it, right? Same way this e comes into picture because of the differentiation logic into it. We don't want to know the proof and all those things regarding that one. The only stuff that you need to know is differentiation actually means you are finding a slope for that particular equation in that particular instant or particular point. Okay, got it? So these all are the differentiated answers that you need to know for solving physics sums. Okay, so then you have like y equals uv. If I'm about to differentiate that one, I'll get u, that will be the same thing u, and then v will be like dv divided by dx. Okay, I'm just going to do differentiation for v, and then again I'll repeat it such a way that you'll have like v du divided by dx. Okay, so in this situation, u is also a variable, v is also a variable. Here a is a constant. When you have two variables multiplied into it, I'll just differentiate it such that first I'll put one thing as a constant and then I'll differentiate the other one. The same way I'll put the next one, the thing that I've left here, I'll put it as a variable constant here, and then I'll differentiate that u in this part. Okay, so these are something that comes into picture while solving sums. You'll get to know all those things while doing sums, as if now these are all of the formulas that you need to know. Okay, so there is a notation that I'll generally give, which will be like u differentiation of v with respect to x is called as v dash, and then you have like v differentiation of u with respect to x is called as u dash. Okay, when I represent it by dash, it actually means I have differentiated it once, okay, with respect to that differentiating element, which is like dx in this situation. Okay, so this is like u v dash and then plus vu dash. Okay, so these are all the basics that you need to know related to the differentiation. Got it? From this differentiation, next we will build integration into it, right? Next, we are about to see integration. As I have already told you, integration is nothing but the reverse thing of the differentiation that we have done, right? So I have taken here like 3 graphs and I differentiated it, right? Okay, let's see. For example, the first graph that I'm going to consider here is the third one, right? Okay, so you have a graph which is like y equals x square, right? So this is what that you have seen in the above cases, and then we found differentiation logic into it. So here you have an equation which is like quadratic equation y equals x square. Now if I am about to differentiate this one, so I'll get obviously y dash. Y dash is nothing but dy by dx, right? So here it was like v dash, which means dv with respect to the differentiating element, which was like dx, right? So same here, the differentiating element here is also x, therefore y dash is nothing but dy divided by dx, obviously, right? So you have a graph which is equal to y equals x square, and then if I differentiate it, I got like y dash, which is nothing but 2x, right? So y dash is 2x, right? So this is like y dash equation. So here in the y-axis you got like y dash, and then in the x-axis you got like x, fine. So y dash was equal to 2x as I did the differentiation into it. Again, if I differentiate it one more time, I'll get like y double dash, right? So if I differentiate it one more time, again the power will come to the numerator. Same way, the power goes to, see, the power reduces by one value, therefore it goes to 0, right? So here you'll have like x power 0, and then only 2 will be left, because 2 into 1 is again 2, therefore y double dash will be equal to 2, right? So you should know this differentiation stuff. The differentiation of this one will be like 0, the again another one differentiation, which means y triple dash will be like 0, right? So this is how I just do the differentiation. If I am about to do this one in forward direction, I'll get integration, right? So what is that sweet spot that you are about to get because of this integration? That is what we are going to find here. Okay, so here y double dash was equal to 2, therefore in the first graph the y-axis should actually be y double dash, right? Okay, if I am about to do this one in forward direction, then I get the integration of 2 will be like 2x. Same way, integrated value of 2x will be like x square, right? So here when I do the integration, let's make it this way. Here I am about to take the second graph. Okay, when I do the integration of this second graph, I get the third graph, which will be, in that situation, the area of this second graph will be plotted as value in the third graph, right? Let me tell you what actually it is. Let's consider the first case, which means for the point 1. Okay, so for the point 1, if I am about to find the area, so for the point 1, I'm about to find the area, so it will be like half into base into height. So base will be like 1, and then height will be like 2, so I'm going to multiply it with 1 half, right? So I'll have like half into 2, which means 1. For this area will be like equal to 1 meter square. Got it? So if I check the integrated answer for 1, you got the answer to be 1, right? So obviously in the first situation, the area of this graph was plotted as point in the succeeding graph, right? So that is verified. So now let us try 2 more extra points. Let's take like 2. Okay, so when you take the next point, which is like 2, so for 2 you'll get the value to be 4, obviously, right? You should understand this one. So if I put like 2 in the situation, 2 into 2, which is like 4, so I'll get a point which is 2 comma 4, right? Now what I'm about to find is, I'm just going to find the area under this graph. So the area under this graph will be like, so the area under this complete triangle, okay, so the area under that complete triangle will be like half into base into height. So base will be like 2, okay, into height, which is like 4, correct? Yeah. So that will give me like 4 meters square, right? So this 4, whatever they note it is, so this 4 will be plotted as point in the succeeding graph, which means in the integrated graph. So for 2, you get the answer to be like 4, right? So it is super easy, right? If I have to find an area under a graph, for a particular graph, I just have to integrate it, I'll get that area, right? Okay, here the limits always starts from 0 and then it ends with 2, right? So these limit stuff and all those things you will learn exhaustively in math. For physics, these things are enough. Same way we'll do all those integration, differentiation in the sums. That too will be easy for you to understand. So what I am teaching here is the logic behind integration and differentiation, which you need to know. So whenever you do the integration, you should get that trigger, which means we are finding area under that particular graph. That is what is needed. Okay, so here if I take the next value, which is like 3, for 3 the answer will be like 2 into 3, which is like 6, right? So you have like 3 into 6 into half. Okay, so if I do the cancelling stuff, you get like 3, so 3 3s are 9, right? So for 3 you get the answer to be like 9, right? So 3 square will be like 9. So in all the situation, what actually happens is area of a particular graph is actually plotted as a point in the succeeding graph, which means in the integrated graph. Okay, so if you want to get a notion or idea behind it, this is like simple thing into it, which means let's consider in the situation dy by dx was equal to 2x, right? What I need to find here is I'll have to find the respective y. If I need to find the respective y, what I should do, I'll have to do the cross multiplication stuff, right? So for dy, I should get something like this, 2x dx, right? So when I do the cross multiplication stuff, what I'm doing, for those every small change in x, I am accounting for all those small change in x, and then I multiply it with that interval del x. When I do that multiplication, I get the change in y. Got it? So 2x is actually the slope here, actually the line here. Same way if I multiply it with del x, I'm just multiplying it with the x term, right? So I'm doing the multiplication between length and then the breadth in the situation. Therefore you get the area of this thing plotted in the next graph, right? Okay, so this is something that you should be able to imagine. So whenever you do the integration, what happens, the area of that particular graph will be plotted as a point in the succeeding graph. Okay, so for here in the situation, it is like complicated to find the area of this graph, right? Because this line is curvy, it is not like a straight line in the above case. Okay, so if I need to get the area for this particular graph, I'll have to integrate it. So when I do the integration stuff, the area under this graph will be plotted as point in the succeeding graph. So that is how it happens. So for those straight line and all those things, it is easy for us to find the area, but for curvy line it becomes hard, right? So in order to get the area for those curvy lines, what we do is we do the integration. So same notion falls into picture for 3-dimensional. In order to find the volume, right, that is beyond the scope and it is not needed. Same way you take like 2-dimensional, you take like 3-dimensional object, and then you take 2 surfaces and you do the integration. Okay, so in that situation you have like 2 parameters coming into picture, which means like dx and then dy. Okay, you will integrate it such a way with respect to z. Okay, those things are not needed. Only thing that you need here is when you do the integration, what actually happens is area will get plotted as a point. That is what you need to know, right? So let me do another one verification into it. Let's say now what I'm about to do is I'm going to consider the preceding graph for this one. Okay, which means this first graph and then the second graph. I'll check those 2 things also. Obviously it will get verified by the way. Anyway, the thing here is first I'll take the first point, which is like 1. Okay, and then this looks like a rectangle. Area will obviously be like 2, right? So for 1 you should get the answer to be 2. Obviously for 1 you got it 2, right? When I substitute 1 here, you'll have like 2 into 1, which is like 2, right? Obviously the area here was plotted here as a point, right? Now let's check the other term, which is like 2. Okay, so when you take the next term, the area will be like 2 into 2, which is like 4, right? So when I check here, it's like for 2 the y answer was like 4. Therefore the area of this graph was plotted as point in the succeeding graph, right? So if it verified in this situation, then obviously the next graph, succeeding graph of this y equals x square, should also be the area that is plotted as a point, right? Okay, so this is what is meant by integration. Okay, so when you do it other way around, the beautiful thing that comes into picture is the area of a particular graph is actually plotted as a point. That is what you need to know. Okay, so that is what I have written here also. When you integrate, area of a preceding graph, which means the graph before, will be marked as a point in the succeeding graph. Okay, So whatever I have explained you here, that is what I have written here. You should be able to get the notion, right? So now let's make a general formula out of it. Okay, there are like 3-4 formulas that you need to know. We'll do that one also. From that, the session will get completed. These are the 3 main integrated answers that you need to know. Okay, so while doing sums, we may do some extra integration also, so we will add it as we do the sum. Okay, so here for integration of x power n, okay, here it's like dy by dx, that is the differentiation. I'm just going to integrate it, right? When you do the integration, the symbol that I use like a long notated s, okay, so the long s is something that we use to denote I'm integrating it. Okay, so here if I do the integration for x power n, so y was equal to x power 1, that's the integration that I'm doing here. There y equals x power n, we differentiated it and then we got dy by dx. Now what we are going to do here is we are going to integrate it. Okay, so when you do the integration, it's like the other way around. There I subtracted the power, so here I should actually add the power, add 1 to the power, which means x power n plus 1, right? In the denominator I put the coefficient in the numerator there. Here I'll put the power in the denominator. Okay, so you do it. So if you do the comparison, you'll get it. Fine. So in the denominator, you'll have like n plus 1, right? So this is the integrated formula for x power n. Okay, for differentiation, it was like n x power n minus 1. Here it is like x power n plus 1 divided by n plus 1. Right, there I subtracted the power, here I added 1 to the power. Right, there I put it in the numerator, here I took the power and I put it in the denominator. Okay, so we should be clear with this one. Then comes 2 things which you need to know. The integration of sin x. Okay, so integration of sin x is actually the negative of cosine x. Okay, fine. So here when I do the differentiation of sin x, I get plus cosine x. Here it is like other way around, therefore it will be like negative cosine x. Okay, same way the integration of cosine x will be like sin x. Fine. So these all are the formulas that you need to know, right? So that's enough, right? You have like 1 or 2 extra things into it which we will do while doing the sums, right? So it just comes up rarely in the questions. So while doing the question, you'll get to know, right? From the 11th and 12th maths that you have studied, you will have like overall understanding of what we have done here, right? So you don't want to know the proof and theory and all those things related to this. What is the proof related to integration of sin x, and all those things are not needed. Just you need to know when you do the integration, you are actually finding the area under that particular graph. That is what is needed. With that foundation, we will be able to have a clear overall picture of the sums that we will solve in the PYQs. Okay, so these are the things that we have seen in this class, which means like distance and then the displacement stuff. That is something that we have seen. Then we just saw what is meant by velocity and then the speed. So in order to get a clear picture and understanding for velocity, what we need to know was integration and differentiation. We did those integration and differentiation, right? So this is the sum up of all those things that we have studied in this particular class. Okay, in the next class what we will do is we will see the graphical thing related to velocity, acceleration, those stuff, and then we will see kinematic equation and relative velocity. Okay, which will be done in the next session. Fine. With this the video gets completed. Bye.